Okay, welcome back to Calculus 2. So in this problem, we are to use Taylor series, and there'll be a table of Taylor series provided for you, okay, to calculate the integral of sine x over x going from 1 to 1/2, okay? Now, this one specifically says use the Taylor series in order to do this, and the reason why is that if I just had to integrate sine x over x dx, there's not a lot I can do with this, okay? Integration by parts, you can try it, but you're going to find that it's going to lead to a bit of a mess before it does anything for you. This is a very famous function. It's called the sinc function. Okay. Electrical engineers are going to use this pretty often, but that's the kind of function that this is. Okay. So how we're going to do this to integrate, how we're going to use the Taylor series to integrate this is that, well, I know that the Taylor series for sine x, okay, is equal to x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, dot, dot, dot. We're going to use the first four non-zero terms. 1, 2, 3, 4. That's all we have to deal with it. Okay. Now, the next thing we're going to do is we're going to multiply 1 over x by this previous series here. So x over x cubed over 6 plus x to the 5th over 120 minus x to the 7th over, and then let's see here. I have got a calculator so we can double check and say, okay, what is 7 factorial? And I don't know that one offhand. Okay, 5,040. Of course it is. Okay, so the first thing we're going to do is go ahead and do this arithmetic. So go ahead and multiply through here. So we're going to end up with 1 minus x squared over 6 plus x to the 4th over 120 minus x to the 6th over 5040. Okay, and now we have to go ahead and integrate this piece. Okay, so this is just polynomial. This is why this is such a powerful technique. It's like, well, gee, I've got to go ahead and convert my function into a Taylor series and then integrate it. But if I convert my function into a polynomial, integration isn't really much of a challenge, right? Because we've been doing harder integrals all semester. This is something you guys learned in Calculus 1. It's like, oh, you're going to make us do polynomials. Oh, no. What should I do? That's a great thing to have here. So we'll go ahead and integrate this. So we have x minus, this is x cubed over 3 times 6, so minus 18, okay? Plus x to the 5th over 5 times 120, because we have to divide by this thing. We'll just go ahead and we'll go ahead and do this. So we have let's see, 5 times, nope, I want 5. So I want 1, 2, 3, 4, 5 by 120 over 600. Okay, minus x to the 7th, and then we're going to have 7 times 5040. So we have here 7 times 5040, and then we end up with 35,280. Of course it is. Okay, so we can go ahead and type that in. So we have 35,280. 35,280. And then what do we have to do after we integrate? Well, we got to evaluate between 0 and 1/2. Well, the 0 part's something I can deal with, right? That's just going to be a 0 at the end of this thing. So we're going to have a 1/2 minus, well, it's 1/2 cubed. So that's going to be 1 over 8. So it's going to be 1 over 8 times 18 plus 1 over 2 to the 5th is 32 times 600 minus, and then we have 1 over 2 to the 7th is going to be 32, 64, 128. So it's going to be 128 times 352, 20. Okay, 35. I don't think that's right. Let me double check that. 35, 280. There you go. I wrote down the wrong number there. Okay, be careful about that. But the other thing we're going to do is double check this. What is 2 to the 7th power? Because that's what I plugged in there. I got 128. Okay. So now we just have to multiply this thing out. You don't have to leave it as a fraction. You can put it as a decimal. That's fine. But we're just going to type this thing out. So I've got 1 over 2 minus 1 over, I'm going to put parentheses in here. 8 times 18. So let's see, we have 8, 8 times 18. Okay, in parentheses. And then we have, what is this, plus? Yeah. Plus, oh, in parentheses. I thought I did that. I guess I didn't. And parentheses. Oh, that's why it didn't. There you go. And I got to use the calculator sticky thing here. Okay, plus 1 over, and then we're going to open up our parentheses here. We'll say 32 times 600. Okay, and parentheses. Okay, minus 1 over, let's see here, we have 28 times, what is this? 35 to 80, to 80. Okay, and then that's what we're doing with all of this. Okay, and that's going to be our answer. Okay, so we just run this thing through, it'll come out as a decimal. Hooray, almost a half. Okay, 4.993566266. Okay, so there we go, 4.99. Okay, 3. And then we have 3566, 3566. There we go. 266. Okay. It'll probably be something like express your decimal out to like, a gazillion decimal places, just because if I leave it to 1 or 2 decimal places, you'll just say, oh, it's 0.5. And then that's, not going to be too bad. It's like you could have guessed. But that's how you do a problem like this. It's very powerful to use Taylor series this way, because a lot of functions we can't integrate them at all. And in lieu of like, well, I can't integrate it, there's other ways to integrate things, and finding out the Taylor series and integrating the Taylor series is usually a really good way to go, because it makes it an easier integral. Okay. I'm going to say thank you very much for watching my video. We'll see you in the next one. Take care until then.